Dear students, good morning. We are in the third chapter Determinants. Already 4 videos I sent, and I think you may follow that one. That is, what is determinant, and some properties are there. Determinant of 2 by 2 matrix, determinant of 3 by 3 matrix. In order to find the determinant of 3 by 3 matrix, we have to know the minor and cofactor. Everything is over. Okay. According to that one, we solved the problems in the exercise 4.1. After that exercise, before going to solve the exercise 4.2, we need to find some properties related with the determinants. This is the fifth part. This is the fifth part. Okay, now property number 1. Already I wrote on the board. You try to understand it well. 3 properties. First I wrote the 3 properties. Again the 3 properties are there. Total 6 properties are there. The number 1. The rows and columns of a determinant are interchanged, then the value of the determinant will remain unchanged. Will remain unchanged. If the rows and columns, total the rows of a determinant and columns both are interchanged. First row is a first column, second row is a second column, third row is a third column, just like. If they are interchanged, that means determinant and transpose of determinant. Both are same. If we interchange the rows and columns in the determinant value, then that value of determinant will not be changed. It is unaltered. It is unchanged. It will not be changed. You see. That is, I will explain. Suppose delta. Delta is also notation for a determinant. Okay, now suppose capital A is a matrix of 3 by 3 matrix of order 3. Then capital A. Then with the modulus, if you write, that is first, it is a determinant. Or det of A. Det A also. All are same. Or simply delta. Delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, now that is the notation for delta. Here vertical bars are there, not curved bar. Curved bars, if there, it is a matrix. It is only vertical. Vertical lines are there. Vertical bars are there. Then that is the determinant notation. And here one more thing is there. You try to understand. Here A1, A2, A3. In the previous, the general matrix A11, A12, A13. Not needed. In order to make the steps clearly. Okay, now A11, A12, it is some clumsy. Of course, actually we have to write like that only. But we may write it also. Some difference is there. A is related in the first row, B is second row, C is in the third row. Whereas 1, 1, 1 suffix, 2, 2, 2, 3, 3, 3, here it notates the column. So, some difference is there. Every element is different from the other element. 9 elements are different. So, okay, delta is equal to the 3 by 3 determinant. Its value is A1 of row and column is related A1 of B2C3 minus B3C2. Okay, now many problems we solve. Minus A2. Why? Because it is a plus, it is a minus, again it is a plus. Always the determinant will be calculated in only the first row. You practice like that only. So determinant is in the first row. Plus, minus, plus. Here is a plus, plus, minus and plus. A1 of its minor is B2C3 minus B3C2. You know it well. Minus, it is minus. A2 of A2 row and column is deleted, B1C3 minus B3C1. Okay, na? Right. Plus A3 of A3 row and column is deleted, B1C2 minus B2C1. Okay, na? What actual? It is say equation 1. It is equation 1. Delta power T, that is transpose. Actually, the transpose of matrix is there. For the notation, transpose T, power T, delta power T, transpose of determinant. That means the rows and the columns are interchanged according to the statement given in the first property. Here delta is this one. A1, A2, A3 the first one. That will become as a first column. Rows and columns are interchanged. B1, B2, B3 is a second row, but here is second column. C1, C2, C3 is the third row. Here it is third column. Now, according to the definition, A1 of, here also it is a plus minus plus only. It is a plus A1 of, A1 is row and column, B2 C3 minus B3 C2, same. Minus B1, minus is there, minus B1 of A2 C3 minus A3 C2, okay na? Plus C1 of row and column deleted A2 B3 minus A3 B2, okay na? It is written there. The first is as it is, you put it. The next bracket, you see there. The second and the third brackets can be expanded. B1, A2, C3. Always maintain the order. A, B, C. A2, B1, C3 na. Here also minus into minus plus A3, B1, C2 na. Here it is A3, A2, B3, C1. Okay na. And the last is A3, B2, C1. The first bracket as it is. Here, observe here. Here, A2 you take as common in the first term, second, third, fourth. Second, fourth terms. A2 is there. A2 is there. Okay, now here A2 is there. Here A2, here A2. If you take A2 as common, minus A2. Here remained B1, C3 plus B3, C1 is there, minus is taken as common. So here it is minus B3, C1. Okay, now? Right. Next, only the third and the fifth terms. In this one, A3 is common. A3 is there, you see there. A3, if you take common, plus term, B1, C2 minus B2, C1. Okay, now? This is nothing but from the equation 1 as it is. You see now, minus A2 of the bracket plus A3 of the same bracket, same terms are included. So here from the equation 1 it can be written as delta. So delta power T means transpose the determinant after rows and columns are interchanged. That is the meaning. They are both same. So even though the rows and columns are interchanged in the determinant, we get the same value. So that is the statement 1. Okay, now we will go to third one. I want to tell the third one, and then we will go to second one. Okay, not maintaining the order. In order to finish here only, the place is very short. That is why I took the third one. Consider. You see, what is the third property? If any two rows or any two columns, any two rows first you take of the determinant are identical, then the value of determinant will not be is 0. It will become as 0. Any two rows, here two rows, any two rows or two columns, the determinant is there. If you take two rows are identical. Identical means all the elements in that row which rows are to be, we are considering. The R columns also. The elements are must be same. I will tell it. Then the determinant value is 0. Is 0 there. Is 0. You see very clearly we can solve by taking this solution. Delta is equal to A1, A2, A3. Okay now? And not B1, B2, B3. Third one is C1, C2, C3. Second one also C1, C2, C3. That means the two rows, the second and third row, this is R1, R2 na, this is R3 na. These two rows, R2, R3, having the same elements, corresponding elements are same. Then we may say that the determinant is having identical rows. They are identical, same. Then what about the determinant value we will calculate among the first one. A1 of, as it is my plus minus plus. A1 of row and column interchange C2, C3 minus C2, C3. Same C2, C3, C2, C3. Minus A2 of row and column interchange. Rows and column deleted. C1, C3, C1, C3. Same. C1, C3 minus C1, C3. Same. Okay now? Right. Next A3. Here the row and column is deleted. Row and column is there. Then we get C1, C2, C1, C2. Only C1, C2. Only C1, C2. Now, you take, after deleting C1, C2 minus C1, C2. Okay now? Here, these two cancel. Here also same cancel. Cancel. So, A1 of 0, A2 of 0, and A3 of 0. Okay now? A1 of 0, minus A2 of 0, A3 of 0. 0 minus 0 plus 0. So, we get a 0. So, it is proved. In the theorem, in the property 3, what is given means, if two rows or two columns are interchanged, are identical, then the determinant will be 0. Its value is 0. Okay now? That is the theorem. Okay? Fine. Okay, students, we solve the two properties. First one is, in the determinant, total rows and columns are interchanged. The value will not be changed. It is unaltered. It will be unchanged. Yes? Okay. And third one, I took the third one, you know it. Third one is, any two rows or any two columns are identical. Identical means, already we will solve it, identical, then its determinant value is 0. Now, I am going to solve the second property. Observe it. Second property. If two rows or otherwise two columns of a determinant are interchanged, then the value of determinant will change its sign only. Its sign, S-I-G-N. Its sign only change. If the given determinant value is plus, then we will get minus. The given determinant value is plus 10 is there, then we will get minus 10. When, if the two rows or otherwise two columns are interchanged. Don't confuse with this first property. Why? Because you see there, here total rows and columns are interchanged like that. In the before that one I solved it. But here the two rows only will be changed, or two columns only. You see here it is very clear. You see then, consider the second property. I am going to solve the delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. That means A related with the first row, B related with the second row, C is a third row. Whereas this suffix 1, 1, 1 column, 2, 2, 2 column, 3, 3, 3 column. First, second, third column. Okay, we know it. Then the expansion is delta is equal to A1 of row and column changed. Related B2 C3 minus B3 C2. Yes, okay. Minus. Every time I am telling, okay, na? Plus minus plus 1. So plus, it is a plus. It is here is minus. Again it is a plus 2. Here 2 of row and column deleted B1 C3 minus B3 C1 plus A3. It is a plus A3. Deleted B1 C2 minus B2 C1. So this is equation 1. Okay. Again we are considering delta dash. Delta dash means not transpose. There we used power T. Here delta dash means some other. One more, it is a new determinant. Notation for determinant. Delta dash means, here you see the second row and third row will be changed. Only 2 rows are changed. In the place of second row, I am writing the third row. In the place of third row, I am writing the second row elements. Okay, now, right. Now, what will be the determinant value? We will calculate. A1 of, as it is A1 of, here B3 C2 minus B2 C3. B3 C2, be careful in B3 C2 minus B2 C3. Minus A2 of, this one and this one will be changed. We get B3 C1 minus B1 C3. Okay, na? B3 C1 minus B1 C3 plus A3 of means the row and column. Then we get these 4 elements B2 C1 minus B1 C2. B2 C1 minus B1 C2. You see here, of course, the determinant value is there. A simple twist is there. I want to interchange. Suppose x minus y is there. It is a minus of y minus x. I will agree. Okay, na? Okay, na? Alpha minus beta is there. Minus of beta minus alpha. Will agree? Like that. I want to change these two. B2 C3 minus B3 C2. Here also I changed interchange. B1 C3 minus B3 C1. Here also the 2 terms in the bracket, each bracket are reversed. B1 C2 minus B2 C1. So total we get to minus. So here it is a minus. Okay, na? Minus of, I wrote all the expression. This expression is nothing but 1 delta. From the equation 1, it is a delta. Okay, na? Delta. Minus is minus as it is. Total the expression in the flower bracket is a delta. Why? Because from the equation 1, I don't need to know. So we consider delta dash is equal to minus delta. Okay, na? That is what we require to prove. Is it okay, na? So here in the determinant, if 2 rows, okay, we may take columns also. Same, we will get the same answer. If 2 rows or 2 columns are changed, not 2 and 3, 1 and 3, or 1 and 2, 2 and 3, or C1 C2, or C2 C3, or C1 C3, whatever it may be. 2 rows or 2 columns are interchanged, then we get only the difference is the sign, SIGN. Plus means minus, minus means plus. Okay, is it clear? Yeah. Okay, now. Okay, students, observe me now. This is fourth property. Okay, now. The fourth property is if each element of a row or a column, of a determinant, row or column, you take any one of the given determinant, is multiplied by a constant k. If it is multiplied by a constant k, then the value of the determinant, now that value of that determinant gets multiplied by k, means it is k times it is increase. Suppose the value of given determinant is 10 and each element of first row is multiplied by 5, you assume. Actually delta is equal to, after expansion, is 10. Its value is plus 10. And the first row of all the elements of first row is multiplied by each element. Suppose 5. Then the value of resulting determinant, that will be 5 into 10, that is 50. That is the statement. Then the value of determinant gets multiplied by k. Okay, now? Right. Now, we'll prove it. Observe it. Consider delta is equal to, delta is the notation for determinant. A1, A2, A3, B1, B2, B3, C1, C2, C3. A related first row, B second row, C third row. 1 is related with the first column, second column, third column. Okay, now? This is 3 by 3 determinant. Its value is A1 of, it is plus minus plus. Every time I am doing. Plus A1 of row column related B2 C3 minus B3 C2. Next, minus A2 of A2, that row and column is related. Okay, now? Then the remaining elements are B1 C3 minus B3 C1. Next, A3 of plus A3 of if we delete the row and column, then the remaining elements are B1 B2 C1 C2, B1 C2 minus B2 C1. Okay, now let it be. This can be taken as, considered as equation 1. Now we are considering delta dash. Delta dash is a new one, a new determinant. In the given determinant, if all the elements of first row can be multiplied by a constant, where k is a constant. It is a constant. Okay, na? It is a constant. If k is a constant and we are multiplying each element of first row is with k, constant k, then we will see what happened, its value. K1 of it is plus minus plus it is Ka1 of row and column related B2 C3 minus B3 C2 minus K2 Ka2 of related, we get B1 C2 minus B3 C1. Next, Ka3 means it is deleted, we get these elements, that is B1 C2 minus B2 C1. You see, in all the elements, K is common. In these three terms, Ka1, Ka2, Ka3, K is common. So totally K is taken as a common. Then the remaining terms are put in a flower bracket. Okay, now A1 of B2 C3 minus B3 C2, it is same as equation 1. You see that, you verify it. So this expression which is in the flower bracket, it will become as a delta. Delta is equation 1. That expression, that value is taken as 1. So from the equation 1, we can write this expression as a delta. K is as it is. So delta dash is considered, we get at last K into delta. Delta is a value, actual value of determinant, that is multiplied by K. That K is a constant which multiplies each and every element of row. Here we are taking first row or second row or third row or first column, second column or third column. Its value be increased by K times. Okay, now that is it. Yeah.